All right, hello everyone. Welcome to the next lecture for Geography 101. Today we're going to be talking all about clouds and precipitation. And so clouds and precipitation is definitely a relevant topic nowadays. We've had some record rainfall these past few months, only getting more and more exacerbated due to climate change. And as we have more warming of the atmosphere, we have more evaporation and therefore more rainfall due to climate change. And so we expect that rainfall and cloud formation to get even worse in the future. You may have seen photos like this of a Michigan dam that broke and destroyed several dozen, hundreds of houses in Michigan due to the heavy rainfall there. That's just one of the reasons why knowing about precipitation and the processes that form it are really important. So rainfall and cloud formation all fall in the hydrologic cycle, which I mentioned briefly in our first lecture, and we'll go into more detail further on in the course. But as you can see, clouds form as evaporation occurs, and then it eventually gets rained out and goes back into the ocean or water sources to get re-evaporated. So this is a cyclical process throughout the Earth. And it all starts with condensation. So there's some just basic concepts about condensation that will be relevant for the rest of the lecture, one of them being relative humidity. So relative humidity is the amount of water vapor in the air relative to the maximum or saturation point for the possible water vapor in the air. And you can see here a parcel of air that has a lot of water vapor in it. It's going to have a higher relative humidity than an area with less water vapor in it. You've probably experienced some areas of high relative humidity before. Important concept too is that water holds more water the hotter it is. So you can see this chart here is as you get hotter and hotter, the capacity for how much water vapor it can hold gets higher. And of course the reverse is true. As you get colder, water is able to hold, or air is able to hold less water. And this can happen all the way to what's called the dew point. So as a parcel of air gets colder and colder, it can reach saturation and condensation occurs. And the temperature at which that occurs is called the dew point. And you have dew forming such as on grass in the morning after a cold night. So that dew point temperature is the temperature at which air becomes saturated and condenses. This same thing can happen for particularly cold places where instead of condensing into water, that water vapor freezes, and that's called the frost point. So remember back when we talked about adiabatic processes where heat is conserved, clouds can form due to the lifting of water vapor in the atmosphere. So there's a number of different ways that atmosphere can lift and form clouds. The first of which is convective clouds. So that's when the surface of the Earth gets warm and that heat expands the atmosphere, and as it expands, it moves up past the condensation level, and clouds form, and it forms this convection or cycling of the air. If you remember back when we talked about the ITCZ in the last lecture, that's the kind of atmospheric lifting that's causing all that precipitation along that line on the Earth. Is that you have the sun heating up the area near the equator, and that heat is causing convection. The second type of atmospheric lifting is frontal lifting, and that's when you have a cold parcel of air that's moving across the landscape and runs into a warm mass of air. And because that warm mass of air is less dense than the cold air, then that warm air gets pushed upwards on top of the cold air, and as it moves up, condensation occurs and rain can form. The next kind is orographic or mountain atmospheric lifting, and we talked about this slightly before as well. So this is when you have water vapor or air moving up a mountain face, and as it does, it cools adiabatically and it condenses and rains out on the windward side of the mountain, and then it leaves the air dry and descending as warm air down as foehn or Santa Ana winds. So that's orographic atmospheric lifting. And then the last kind is convergent atmospheric lifting. You might remember this from the polar vortex, for example, is caused by convergent airflows. And so what you have here is two warm air masses that are colliding with each other. And so as they collide, that air has to move somewhere. You have that air gets pushed upwards as they collide because there's not really anywhere else that it can go. And as it rises, clouds can form. So those are the four types of atmospheric lifting that we see on Earth. So next we're going to talk about different types of clouds, and I recommend checking out this diagram. It's very useful if you ever want to classify different clouds, such as in your photo assignment. And so most generally, we classify clouds in three different layers: high, medium, and low altitude clouds. And then there's some specialty clouds as well that we'll go into in a second. So those low altitude clouds are called stratus clouds. They're nimbostratus, stratus, or stratocumulus, depending on how clumpy the clouds are. And those are generally around 2,000 meters. And then higher up, we have alto clouds, so altocumulus and altostratus. And then the highest clouds are cirrus clouds, cirrostratus, and cirrocumulus. So cumulus clouds are the very nice, fluffy, round, cotton-like clouds that you might see on a really nice sunny day. They're usually flat-bottomed, like you can see here, and like the clouds that we saw formed through adiabatic cooling. And so you have a moisture source that's rising, and as it does, then it reaches that condensation level and clouds start to form. And that's cumulus clouds. They tend to be fairly low altitude, 2 to 6 kilometers in elevation, are considered altocumulus. You can also have stratocumulus clouds and cirrocumulus clouds. And generally they're a good sign of clear weather and not much precipitation. So if you see this, generally you don't have to worry about rain. Next we have stratus clouds. So these are thin sheet-like clouds that cover a large portion of the sky. And they're generally found for altostratus clouds, at least, between 2 and 6 kilometers as well. And because there's more moisture in the air, they can sometimes be associated with light showers and drizzling, but generally not associated with very heavy downpours. So mainly these type of clouds are formed when a large air mass cools and you have that warmer, moisture-rich layer of air that falls and reaches that condensation layer. Cirrus clouds are the highest clouds, usually found over 6 kilometers in altitude, and they're very light and wispy, mainly composed of ice crystals. They can get down to negative 50 degrees C. It's very cold up that high in the altitude. They're also known as mare's tails because they kind of look like the tail of a horse. And they're generally associated with fairly warm weather, but also they can indicate that a distant storm is coming too. So while it may be warm at the time you see them, there might be a storm approaching. And the reason why cirrus clouds are associated with warm weather in general is because they're very good at reflecting long wave radiation. Remember that any object, depending on its temperature, will emit radiation. So the sun emits visible light, the earth emits infrared light, and for cirrus clouds, when the Earth is emitting that infrared light, that heat, the cirrus clouds are able to reflect a lot of it down. And because the clouds themselves are fairly cold, they're not emitting that much radiation themselves. And so they tend to have a warming effect as they reflect and cause that kind of greenhouse effect as they warm the Earth more than they cool it. The next type of cloud is Cumulonimbus Clouds. These are also known as anvil-shaped clouds because they generally have this large top here. It's kind of an anvil shape, you can see. And these are also known as thunderheads because they cause lightning and thunder and hail as well. And so whenever you see these clouds, they're usually associated with heavy downpour and really extreme weather events. And you can see a diagram here of those clouds. They're usually caused by a warm air mass colliding with a cold air mass and getting shifted upwards. And so as that warm air mass lifts up, it condenses, and it reaches all the way up to the top of the troposphere, the tropopause, and can sometimes even overshoot that. And when it hits that tropopause, it spreads out and forms that anchor shape. And so underneath this anchor, you'll have heavy downpour as you have cold air dropping down. And you can also have a number of different cloud formations, such as these roll clouds, as you have turbulence at that convergent zone. So these are very dramatic cloud formations that you should be aware of. The next type of clouds, my personal favorite type of clouds, are called lenticular clouds. And these are saucer or spaceship or lens-shaped clouds that form over mountains. And they're very cool looking if you ever get a chance to see them over a very mountainous region. And they're formed due to orographic lifting. So as a parcel of moist air gets pushed upwards due to the mountain, it'll form this lens shape, and that lifting kind of forms a wave of air movement as it rolls across the landscape. And so you can sometimes have successive lenticular clouds kind of all up in a row and also stacked up on top of each other. So that's lenticular clouds. So fog is a type of cloud as well. So fog is just a cloud that forms at ground level instead of at elevation. And there's a number of different types of fog as well. So the first type is called radiation fog. And so that's just when you have the ground warming and it radiates heat into the atmosphere, and that heat causes the atmosphere to warm and rise until it's adiabatically cooled to reach that fog limit. that condensation limit. And so it usually can fill up an entire area. Advection fog is when you have warm, moist air that moves over a cold water body, and as it cools, is cooled by that water, then it can reach below that saturation limit and form clouds. Then you have orographic fog, similar to orographic lifting clouds, but close to the surface. So orographic clouds are just when high moisture air gets pushed up to the mountains, and it kind of hugs the mountainside and condenses as it cools. And then lastly, we have evaporation fog, which is when you have heavy evaporation from a warm water body, such as a lake or the ocean that's being warmed up by the sun. And as that mass of water vapor moves onto land and hits a colder air mass or colder area of land, then it'll start to form fog as it reaches that saturation point as well. So those are the four types of fog that we see in our atmosphere. All right, let's take a break and we'll come back in just a minute.